Okay, great. I will just keep on admitting people as they come. But yeah, let's get started. So welcome everyone. Thank you very much for coming. Today we wanted to talk about a new feature that we've recently launched, which is pipeline deployments. The majority of what we're going to talk about today is something that Hamza is going to go through. We're going to have a nice lengthy live demo. We're also going to have a whole bunch of time for questions, your questions. If you do have any questions during the meeting, please drop them into the Q&A function. I think it's in the bottom right-hand corner of the Meet screen. I will either interrupt Hamza in whatever he's talking about, or we'll tackle them at the end. And yeah. So kind of today's agenda, we're going to talk a little bit about the prehistory of ZenML and pipelines, how we got to this point. We'll also talk about just pipelines in general, what role they represent in the kind of machine learning and AI engineering space. Then we're going to have a demo, and then we're going to talk a little bit about the kind of the implications of that, what it means for putting your pipelines into deployment in production, and then we're going to have time for your questions. Just a little bit of background. I'm Alex. I'm based in the Netherlands. I've been at ZenML for 4 years or so, working as a machine learning engineer. Hamza, you want to briefly introduce yourself?
Yeah, I'm Hamza. I'm the co-founder and CTO of ZenML. Also ML engineer by background. Very happy and excited to talk about the evolution of ML pipelines today.
Nice. So I think we can just dive into it, Hamza. You want to take it away?
Yeah, let's do it. I think that a lot of the people who I recognize in the call and hopefully watching on YouTube pretty much might have followed this journey as it evolved. But like as Alex mentioned, we thought we would start and take a little bit step back historically before we dive into what AI pipelines or AI workflows are today, looking back at how we got here. So I was extremely fascinated personally with pipelines in this first generation. Somewhere I started my career around 2014 or 15, where essentially most AI pipelines or AI workflows were cron jobs. They were just scripts, mostly written in Bash, but sometimes executing Python or some esoteric language. And there was an obvious problem with this in production because, as you can see, if you have a sequence of steps to execute data transformations like extraction of data, training of a model, deploying a model, what happens if the extraction fails, or what happens when the deployment fails and you want to go back from the deployment all the way to the extracted data? What happens if you want to coordinate a synergy between the sequence of those steps within a particular namespace or a time sequence? So even in the best of class companies like Airbnb, we had problems which eventually led to the rise of, I would say, the first iteration of these pipelining tools, mostly exemplified, I think, by Airflow, which was really the classical data orchestration, data pipeline tool. It's still the most popular by far. With Airflow 3, they have also undertaken this journey from these Bash scripts, orchestrating those to now orchestrating agents. In the middle of that, of course, there were many evolutions. We were part of that. So like just a personal anecdote, when I started our previous company, a lot of our team that is here today was with us back then as well. And we were one of the early adopters of TFX, TensorFlow Extended, which was an attempt by the ML community at that time at Google to sort of fix the problems of these data schedule-based orchestration systems like Airflow into something which is more ML specific. And I think it was a great attempt. So you can see the evolution of having cron jobs go into like, statistics gen, schema gen, and example validators, like all of those things that you might recognize from training pipelines or deployment pipelines with the pushing of the model. Of course, that came with its own problems. First of all, how rigid they were. So while TFX was an exceptional tool for its time, I feel like it did suffer from its time period. It was very static. If you couldn't do anything really dynamic. And of course, the biggest thing missing here was observability. So if you were to author and deploy a DFX pipeline, they relied largely on Airflow or Kubeflow to orchestrate that. So the underlying orchestration backend was considered the observability interface, and that handoff was not a trivial one at all. And since then, of course, things have evolved. So there are other pipelining tools like, let's say, Prefect or Daxter or ZenML as well, who've taken some of the concepts of DFX and have put them into these mostly batch workflows of doing distributed multi-node jobs. And I think by the point of 2025 where we are, those workloads, I think there's a large standard of how to write and execute those. Of course, a funny anecdote is that when ZenML started, DFX was a dependency of ZenML. Some of you might remember. So a lot of the frustration that we got from DFX, we actually took and we tried to smoothen out around the edges. We had to rip it out at some point, right, Alex?
I think it was about 2 years ago now. We pulled that out. And...
Yeah. But we are. I think we were very involved in how pipelines needed to be described and how intermediate representations of pipelines for multi-orchestrators needed to be orchestrated. I think it was very good for that time.
I think also the industry back then was also still evolving. Standards were still being made somehow, just as we're now starting to see with agents, which I guess we're going to talk about. We needed as an industry to kind of figure out what this stuff looked like.
100%. Things like compiling server-side, compiling client-side, all those things. Like I feel like we just had solved when we got hit by ChatGPT. Of course, which led to a lot of the industry shifting from train-first workloads to test time compute, ultimately yielding things like these. So I think as of today, I would say most agents, as they are described, are essentially pipelines. So what does that mean? So if you are to give full agency to an agent, it creates its own pipeline. But the fact of the matter is that that doesn't work in most cases. So you need to take away some of its agency. And the moment you start taking away agency and you start giving a plan to the LLM, what you essentially are doing is you're daisy chaining LLM calls together, and you're basically versioning artifacts that flow between that. And for all intents and purposes, that is a workflow, that is a pipeline, something that looks like this. However, that is not to say that the same pipelines that existed in the previous times can just be used like that. And that's why I think tools like LangGraph or even no-code tools like n8n and the recent OpenAI workflow builder have gained in popularity, because I think the industry as a whole has taken a step back and gasped and treated these things as new, even though a lot of the fundamentals of pipelines do remain the same. Of course, the key difference being that rather than these pipelines being multi-node distributed, where every step is orchestrated in its own compute namespace, in its own data space, these are conventionally single node, fast, low latency requests. So if you're talking to a chatbot, you want it to be fast. You also have this whole paradigm of streaming and async that is very critical. And of course, the way context is maintained is not exactly the way we store artifacts of a machine learning model training pipeline. So those caveats aside, structurally, that the nature of a pipeline has remained call a step, maybe have a condition, maybe fan out, fan back in, return something, and track that. So that's really where we are today with pipelines. And I think that's why we are very excited to, internally at ZenML, we thought a lot about how we could evolve the pipeline interface that was very good for that previous generation, which is still quite relevant for training models and evaluating models and agents. How could we put a step forward into that world of real-time single node agentic applications?
It's maybe worth just taking a second to kind of double click into that, because this is somehow a spicy take, right? That you can use pipelines for agents just like you did for traditional machine learning. Could you say a little bit more about that?
Yes. I mean, I feel like we've had many conversations. As I said, I think that actually it isn't as spicy as it used to be. Like I do feel like if people like OpenAI release a workflow builder that basically connects steps together, I think essentially what you're doing is you're building a pipeline. I think the failure of maybe the core LangChain library and the rise of the LangGraph library is another indicator in the Python works sphere, why graphs are basically considered very good mental model of LLM calls flowing through each other. Of course, the matter of acyclic, or the fact that these things are acyclic and not cyclic, that has yet to be determined. I do think that tools like ours need to add cycles into themselves to be, lend itself into these truly recursive LLM calls that do tend to happen in production. You can wait a couple of weeks for that announcement. I mean, that's coming as well. But yeah, apart from that, I think it's maybe not as spicy as it used to be. I think there's enough players and enough agents in production that look like a pipeline and act like a pipeline that we can just call them a pipeline.
And I guess all the things like that you would expect from a pipeline, you also expect from an agent as well, of robustness and retries and all of that.
Mm-hmm. Yeah, exactly. I mean, you need, at the end of the day, you need to have rollbacks. You need to be able to track and observe the calls. You need to be able to retry them. You need to be able to dockerize them and have have an understanding of how these agents code, config, and data has evolved over time.
Nice. I think it's time to maybe get a bit practical.
Yeah, let's do it. So I think this is the part where everybody sort of logged in for that. Yeah, so we're very excited to. This is the first time we're demoing this, so forgive us if this is not perfect. But what we're going to do today is we're going to talk about pipeline deployments, where rather than deploying pipelines as ZenML pipelines used to be, in a batch way, where you used to have training models or evaluation of models, with the underlying backend being an orchestrator like Airflow or Kubeflow or SageMaker or Vertex or something, which actually took maybe 10 minutes to spin up the nodes in some cases. Now we have introduced deployments, which essentially what they do is they take the same pipeline syntax that you already had and then essentially wrap them into an application, a service. We're using FastAPI at the moment, but there's no reason this couldn't be some other service. That's another abstraction. And then gets deployed with this new component that we've introduced, which we call the deployer component. So whenever you invoke this endpoint that gets created, a run of ZenML is created from that pipeline. But I think this is easier to show than to explain with words. So let me just present my entire screen now, and we can go from there. All right. So Alex, feel free to throw questions at me or stop me if I'm going too fast or too slow.
Sure, will do.
I thought it would be nice maybe to start with a classic machine learning pipeline, like something that trains something. So we have in the examples of the ZenML now something called deploying ML model. And you can see we have a training pipeline and an inference pipeline. The training pipeline looks like your classical training pipeline. So you generate some data, you train the model, and that's really it. We don't do much in this particular example, much beyond that. But let's see how that looks like in ZenML. I need to install scikit-learn. Okay, this is not starting as I wanted. Let's try again. Okay, so while that's running, let me just show you. I mean, for those of you who are new to ZenML, maybe this syntax might be new. So in ZenML, what you do is you take what we call a pipeline function, you decorate it with the pipeline decorator. This pipeline decorator, its job is to declare the tag. So its job is to put together steps. And how do you put together steps? Very easy. So a step is another step function. So just a Python function that gets inputs and returns outputs. We have the step annotator for that. So you can, in essence, declare any standard Python function as a ZenML step. And once you chain, like daisy chain those things together, these things become artifacts, these things become steps, and together it's what we call a pipeline. When I invoke this pipeline, I create a run. So that's what I just did. So in the run.py file, what I've done is I've simply called that pipeline. And if I open this guy up, you can see in my ZenML dashboard, in this project, I have now a new pipeline. Within this pipeline, I have one run. And this run looks like this. So this is, again, everything that you might want to have as observability. So you have things like the code, same code that I ran locally, of course, is tracked. You have the logs, configuration, what went in, what went out, stuff like that. These steps produce artifacts, as I said. So if you want to see what the input data looks like, it looks like this. This happens to be a churn prediction model. So it's taking input from, let's say, an e-commerce website, and it's trying to figure out when people will churn, or any SaaS subscription website. And it produces a scikit-learn pipeline, like not to be confused with what we're talking about right now. So I think that's a overloaded word. But scikit-learn has this concept called pipeline, which basically wraps a model. You can see that I have one version of this model right now. But if I ran this pipeline again, I would, of course, be creating another run, which would create yet another model artifact. So let's wait for this. You can see it creates another run. We go back. And now, voila, we have two runs. And if I go into this, you'll see that this is probably version number 2. And if I wanted to see all the versions of my churn model, I would be able to go into my artifact control plane in ZenML and see these two. Of course, if I wanted to see the metadata of one, the accuracies, stuff like that. I mean, I'm just sort of rushing through this because I assume a lot of you are familiar with this. If you're watching this video, we have, of course, beginner tutorials for those of you who are new to ZenML as well. So that just lays it up for us. Now, normally at this point, what would you do? So you have a model, it's stored somewhere in S3. It probably has some pre-processing associated with it. So at this point, if I'm being honest, in the last few years, the flow of ZenML was a bit not perfect. So we did have these things which are called model deployer abstractions for the stack component. And I'll freely admit publicly that this was not the best abstraction, and a lot of users and customers did struggle. So a good side effect of having served pipelines or deployed pipelines is that we are also able to solve not just agentic problems, but also the problem of serving models. So let's say in inference time, what do I want to do? So I want to basically load in the model and run prediction on some real life data, right? So this, again, you can define in a ZenML pipeline. But the problem is that unless I'm running in batch inference, the latency of a ZenML pipeline to run would take just simply too long of a time for any real world application. So what normally users did was they extracted that artifact out of the S3 store using the ZenML API, and they had their own process to deploy this model, or maybe some of them use Seldon or BentoML or some other service to wrap their models and serve them. What we noticed over the last few years is that a majority of people did not use specialized model serving frameworks for good reason, because we have already fast API, which essentially solves a good majority of, let's say, smaller model use cases. And unless you don't have specialized needs, like if you're serving large language models or something like that, that suffices. So if I'm serving a small scikit-learn model, I don't really need anything so special, especially if I'm serving for an internal model in an enterprise. So this use case we thought we could make a lot easier. So here's how we did it. So now I could, of course, run this pipeline, and I believe there's a way to run this so that I can run it in batch mode. So yes, I can do a predict. This will do what you expect. So it will essentially call the inference pipeline. It will load in the model that I just showed you from the ZenML artifact control plane, load that in, take the live data, run the prediction, return the prediction. And yes, that's great, but it took already a long amount of time. And you can see here in my inference pipeline, yes, I have my prediction at the end of the day. So this happens to be a small model. It was still relatively quick, but you can imagine that it's not really made for invoking in a real-time API. But if I wanted to do that, this is our transition to ZenML pipeline deployments. So if I wanted to deploy the same exact pipeline with the same syntax in a real-time way, well, now I have a new command in ZenML, which we call ZenML pipeline deploy. And what that does is you simply need to point to the module and to the actual pipeline function. So in this case, it's in the pipelines module, in the inference pipeline, and the function is called journal inference pipeline. And now suddenly something really interesting happens. So you can see how quick that was, and now it's giving me new information, right? So let's go back to our dashboard and see what happened. So if I go into my pipelines, we have a new tab in ZenML, which is called deployments. Within deployments, I have my pipeline deployment, my first pipeline deployment. If I click into that, I can see a lot of information. So I can see, of course, the stack. We'll get into that in a second. But I also have things like invocation things. I have an endpoint. I have things like configurations. And if I actually take my endpoint, I can actually see locally, suddenly I have a fast API running, which lets me invoke something. To make this a little bit easier, we have the curl command. So I can just copy this curl command, which essentially just calls this invoke function. And I can paste this into my terminal. And very quickly, we'll see how this pipeline was executed. So you can see how quick that was. That's in orders of magnitude faster. And suddenly, I have a new run here. So this run basically looks like the same run that we saw before, except that it was executed through this API. There's also subtle other differences within this run and the other runs we used to have. And I'll get into that in a second.
Also, just one question at this point. I guess, what's the difference in terms of latency, in terms of like doing it with the ZenML deployer?
Exactly. So basically now the fast API instance essentially executes the pipeline function as Python. It doesn't distribute it out into multiple nodes. So every step runs within the same process, within the endpoint. And that, of course, is very similar to how you would model any API, right? So that naturally makes it faster. The other thing that happens is that we have options to turn off log tracking and to turn off artifact versioning per artifact. So you don't need to, maybe in this particular case, track each and every artifact that comes through the pipeline, but maybe you just want to track the last one, or maybe you just want to track the first one. So, and we also have some advanced features for sampling these and making it even more optimized for production usage. Alongside that, we have a very easy playground, which we're going to develop. So if you wanted to play around with your inference API, you could simply use our playground. That does the same thing, and it gives you a nice visualization as a markdown and as JSON. I can keep playing around with it. Every time I run it, there will be a new prediction created. I can compare these predictions if I wanted, et cetera, et cetera. So that's in the classical machine learning. So I haven't really even gotten into the agent stuff. I'm just saying that this feature already unlocks something that ZenML users probably struggled with before, and we're already excited for this part of it. Any questions so far?
We have some questions, but they're all a little bit towards the agentic side. I guess one was kind of, around A/B testing of these different versions of models and so on that you're deploying. Yeah. How does that work in ZenML?
Yeah, we'll get into that. I think that's a really good question. I would be remiss not to talk about the custom UI with this. So one of the things that we internally brainstormed was that essentially what we're doing is we're wrapping fast API. So one of the things we want to do is not get in the way of people building fast API directly. So we've worked a lot around the abstraction of the deployer, as we call it, to make internal fast API things very available to users. So if you wanted to inject middleware, your own security stuff, you can do that through the interface. And indeed, there's extensive documentation to help you, go to the level of cores or something like that in the deployment settings. One of the things which we thought would be useful for users, both in the classical world and in the agent world, was that, of course, if you're serving fast API can also serve HTML files. So why not give users the ability to serve their single page applications through ZenML as well? So all you have to do for that is you give a path to a folder called, in this case, I called it UI. And in the UI folder, I have an index HTML file. And because all we're doing is we're packaging these things and deploying it, we are actually able to serve, for the first time, full applications behind pipelines in ZenML. Which means that if I click into this application in the root URL, I can actually create a custom UI for my model or for my agent. I don't know whether you have a chatbot or whether you have a, I don't know, like a specific, what you might have done with Streamlit or something, like a similar experience with radio. You can do that here as well if you just compile it statically to HTML. So I'm able to now run predictions through this nicer UI with ZenML as well. We thought that was pretty cool, especially in the world of vibe coding, where you can vibe code UIs pretty easily.
I'm sorry, is the idea that people would use these applications in production, or is this kind of just for internally for teams to test things out? Yeah.
I feel like it's great for a POC, right? If you're showing your managers your model or you're showing your managers your agent, it's great to have a UI slapped on top of it rather than developing it separately. So definitely at the POC stage.
Kind of like we had with Hugging Face Spaces and how popular they became.
Exactly. I'm not sure whether people would actually want to serve the front end to users. I think it's largely dependent on the use case. I imagine why not, like as long as the backend scales. But of course, ZenML is classically a backend service. We are not so front end forward, except for our own front end, which has its own playground now. But I think the world is getting more and more into custom UIs, custom things, because simply the barrier of entry of creating these UIs is so easy now. So I think that we will go along with that trend. Cool. Are we at a good time?
Yes, I think we're good to head into the world of agents now, I guess.
All right. So agents is actually pretty much the same, right? And this is, I think, our point, basically. So if you think about an agent, what is it, right? So let's take a look at an agentic pipeline that I've created. So this has a lot more customization around it. I think it's a good, by the way, if you ever wanted to learn about the ZenML deployer abstraction, I think it's very good to look at the weather agent example inside the examples repo, which has a lot more customization of fast API around. But essentially, we have created an example agent. It's a boring agent. It's nothing crazy. What it does is it takes a city and it gives you some weather using an LLM, right? So what we're doing here is I can, of course, model this as a ZenML pipeline. Again, all of these things individually are steps. All of these things can analyze things with LLMs, and I'm using the OpenAI, I think, client for that. You can use whatever framework you want. You can drop in LangGraph in there. You can drop in whatever esoteric agent framework you're using. We're gonna treat it the same. And then, of course, you can run this in batch mode. So if you wanted to just quickly run here, I can probably need to switch to that repo. So let's run it here. Of course, it's the same. So it's going to ask me, and I say, okay, let me give me the weather recommendation for London. It's going to start. You can see there's already a little bit of overhead for initiating the new run, logging that all in. Oops, it's already building. Okay, I'm on the wrong stack, but let's give it a second. Yeah. Oh, I haven't initialized the OpenAI key. I'm going to have to do that off screen. Just give me 1 second. I'm going to export my API key. I don't want to leak that. Clear my terminal, come back. Okay, so we're back. So anyway, I think you get the point. So we have a pipeline, we just ran it. And of course, we can now serve it as well. So let me make sure I have the right stack. And let's serve it. So I didn't do anything different from the last example, right? So whether it's serving a model or serving an agent, it's the same. And now I have, suddenly in a few seconds, I have wrapped this in a fast API, and now I have my invocation. And here you can see I have my custom UI for the weather agent. I can ask it here directly, give me, some activities to suggest in London, and it will go and do its own thing. Of course, this is a little bit of an agentic loop, so it does take a little bit more time. And then I can style it as I want and get the recommendation. You can imagine doing this with chat APIs. You can imagine doing that with uploading PDFs for document extraction, stuff like that. In the ZenML dashboard, this looks the same. So I have my new weather agent deployment. And I have everything here. So you can see my endpoint. I can see all the runs that it ever ran. I can play around it. Let's say San Francisco. And I can do this here as well. So I think this is basically the point, right? So if you're going to have a fast application that has steps that do something that you want tracked and you want observability over, and you want quickly deploy it with abstraction of the backend interface, I think this is a very good tool to get started. And I think it's a very good tool to go into production with as well, because you get all the goodies of ZenML alongside with it, which I'll get into after a while.
I guess the obvious question is, how does this scale and so on when you're deploying to the cloud as well?
So that's, I think, the end of the presentation. So essentially, ZenML does have the concept of stacks, right? And within stacks, we now have a new component. This component is called deployer. And this deployer, which I was showcasing the whole demo, was the local version of that, which basically just serves this locally. But we have Docker, we have AWS, we have GCP, Kubernetes is in the works. Azure is coming up as well. And of course, being ZenML, we're extensible. So you could create your own component for your model or whatever else deployer that you wanted. I want to show you a quick demo of how you can go from local deployment of this to GCP. So within this particular ZenML workspace, I have a GCP deployer. And all I need to do is I need to switch my stack to this particular thing. Let me actually show you how that stack looks like. So you can see here, this has a new deployer, which is called GCP Deployer Cloud Run, which is a backend service that we use to serve these things. And I can basically do the same thing I did before. I'm going to give it a different name. And ZenML is going to do something different. So rather than having, let's say, like running it locally, what it's going to do is it's actually going to build a Docker image, push the Docker image to GCP, have all those authentication, like that stuff that we've been working on for years. That's already baked in. And then it's going to push that onto GCP. And you can also build the image in GCP if you wanted. And then it's going to start provisioning this on Cloud Run without you having to really figure that out. So it's very seamless and very easy. I've been doing it for the last couple of weeks. Just really enjoy it. And at the end, it will spit out a URL or a deployment of the same exact thing. Yes, this would run as a, yes, you're right. This would run as a cloud run instance. Let me actually show you how that looks like on the GCP side. Let me pull that up here. So this is GCP in cloud run. You can see that this just sped up just now. And if I go back into my code, it's probably live already, yes. And let me go to my ZenML Pro instance, into my projects, deployments, weather agent GCP, boom. This endpoint is live. It's probably publicly available, so you can actually just go into it and run run it again. Of course, with that comes the ability to scale that up and down and all those things that you want to do. So it's actually very easy and very handy. You can add authorization, you can add rollbacks, you can go back to deployments all through ZenML as well. But I think those are a little bit advanced. For now, I think the idea is that we wanted to show you how easy it was to go from 0 to a deployed agent with ZenML. We also showed you how you could serve an ML model through ZenML. So I already feel this is a step in the right direction.
That's already pretty cool that you can so quickly go from local, just in terms of like developer experience and like to be able to experiment and to have an actual endpoint that you can, yeah, pass around to your team perhaps.
Exactly. Cool. I feel like we're already at the end of it. I might have ran a little bit over. Yeah. Do you want to?
We have a bunch of questions. Maybe you can just kind of get to the end and then we'll get to the questions. I think batch them all together that way.
I'm not sure how much is left. I think basically it's a wrap up. So essentially, let's take a step back. What have we seen today? So with ZenML now, you're able to not just serve batch pipelines, which are slow and meant for more batch workflows that do not have any particular latency requirements, to single node, fast, customizable, like real-time services. You have with that for free things like automated tracing, authentication, auto dockerization, robustness, rollbacks, retries, and use case agnosticism. So you can model your agents within ZenML. If you want, you could even have one step that does something super deterministic, that have an agent do something, then return something. And all those steps will be tracked within ZenML, within our tags. So you would get these sorts of, clear visibility over what's happening, how long things take, everything that ZenML already brings you out of the box, including logs and stuff like that. That's really why we're excited. But having said that, I want to caveat this by saying that this is version 1 of the vision. We are, of course, working a lot on making things a lot better. So, of course, we're targeting making this scalable. So you might be wondering, what overhead does ZenML add on top of Fast API? There is a little bit of an overhead, but we're trying to mitigate that and making that as little as possible so people can really scale out. We have still some work to do around things like logs and tracing. Like tracing, especially our vision for tracing is that we don't want probably tracing embedded into ZenML itself, but we already have tools like LangFuse or LangSmith. So we would probably come up with a new stack component abstraction that lets you connect your tracing tools to these fast API deployments, and you can link your pipeline runs to your traces. For prompt versioning, of course, that's a big, like somebody asked about A/B testing. We have basic A/B testing and comparisons in ZenML, but we have a long ways to go and we have many ideas. So how do you compare different deployments? How do you compare different runs? How do you compare different prompts? So there's some exciting new features that we're working on that would make you editable artifacts within the dashboard. So you'd be able to edit your prompt directly and test them and run these deployments directly from ZenML itself. And lots more. So we have lots of ideas. We have less time than ideas. And I just want to caveat this by saying this is the start in the step of real-time ZenML pipeline deployments. We hope with your feedback we can grow. So that's going to be my last slide. ZenML has developed in the last 4 years because of the community. We have so many users that give us feedback daily. I love talking to every one of you. If you have some feedback for this new feature, this new direction, this new evolution of the product, we would love to have it. You can go to the open source repo, pip install ZenML, deploy your first pipeline within a few seconds, come on Slack and let us know what we're doing wrong. If you're an enterprise and you're looking for some pro features, of course, we have the pro product. You can scan the QR code and book a demo with us. We're happy to give you a free trial as well. And that's pretty much it, Alex.
Yeah, I think we should get into some of the questions. Clear, the agent builders are out in force today. So I guess kind of grouping them together, obviously there are some questions of, will ZenML have stack components or ways of abstractions dealing with things like memory and so on. Maybe you can talk about that, but also just in general, there are questions about long-running pipelines which perhaps need human in the loop or whatever, like how does ZenML handle that? Can you talk a little bit about like ZenML and agents?
Yeah, so I think the big vision of ZenML is that we waited a few years for ML ops to settle down and we created these abstractions. I think with agents, we waited a little bit for the abstractions to show up. I feel like one abstraction that I already mentioned, the tracing abstraction, the ability to set up traces, there's value in that because you already have tools that do that, and you might want to group together traces and complete this outer loop of agent development. So I think ZenML can give a lot of value there. On the other hand, memory is, I'm not sure. I think, Alex, you have opinions on this. You always were, I feel like on the side that memory is not a stack component yet. Like where are you on that?
I kind of feel like memory is going to go the way of vector databases. Like there's like this little peak and a ton of investor money and so on. And like later on, it just becomes, something less like a unique stack component and just part of the way you do things. Yeah.
Yeah, what I will say is that we are going to expose the session IDs of Fast API through the pipeline interface. So if you wanted to do something where you wanted to maintain multi-turn conversations within the ZenML pipeline deployments, you would be able to do that just like you do today with Fast API. So we're not blocking you from that. As Alex said, I'm still not sure where the stack component abstraction lies. So that's something we're going to have to figure out.
And I guess, obviously you have this idea of kind of a multi-agent setup and agents talking to other agents. How would this paradigm work with that somehow? Like, can you have like nested pipelines or nested agents somehow? How is ZenML dealing with that?
I think ZenML will give you the metadata that you require to understand things like, you have your MCP, you have your tools. I feel like you want to know which pipelines or which agents are talking to which tools and which MCP servers, what are their configurations, what are the authentications. I think there's a lot of things that ZenML can do around that. As for whether ZenML would allow inter-agent talking or conversations, I don't think that's what we built this for. I feel like we would just imagine you doing that within the step. So if you have like a multi-agentic step, you are happy to do that. So you can just put like an army of 20 agents within a ZenML step and then have something happen before, something happen after. But we're more concerned about the outer loop of development rather than the inner loop of the agent.
And why is that? Is that something we've observed with customers?
Because there's so many tools that do that already, which are very good and they should be used. So like there are tools that are specialized in like I don't know, something like Crew AI or LangGraph or LangChain or LambdaX. Like they do the inner loop very well, but the productionalization aspect is what they don't think about, or maybe they want their managed solutions to worry about that. And we are really, I guess, the open source version of that you can just connect your own, I don't know, AWS, GCP, or your own Kubernetes and do that yourself.
We had one question about kind of the observability point and whether we're going to kind of integrate with OTel and so on. I can just answer that. Yeah, that's the aspiration that we're going to basically have a traceability experience similar to the kind of tracking tools that we already have in ZenML, where everything just kind of gets auto-logged, whether it's MLflow or weights and biases or just natively within ZenML itself.
Yeah, I think Barish was working on the OTel extension. OTel is generally something we need, not just for agents, but we need to emit OTel spans and traces just from ZenML pipelines. And we're working on that right now. So that's good. That's in development.
We had one feature request for a Kubernetes deployer. I guess you can break the news on that. Already in the works.
I think Safwan already has finished.
Started a PR.
Yeah, so the pull request is almost there. I think it's pretty easy to add a deployer, honestly. It's not such a complicated component. It's not like an orchestrator. An orchestrator has to deal with GPUs and also to deal with all this sort of stuff. I think just a deployer that deploys a container somewhere, it's very easy for you to write that, and we'd welcome community contributions.
We had kind of one question about from Samir, which I'll just read it out. Can the same deployed agent pipeline be versioned or redeployed automatically when we retrain or fine-tune the LLM component? So I guess this is this kind of hybrid flow where within ZenML someone is fine-tuning something maybe.
So one thing I haven't talked about in this webinar is snapshots. Snapshots is another feature that we released with 0.91, which essentially creates a reproducible copy of your code, your configuration, your Docker image at a moment in time. I'm not going to go into the details there, but basically you can deploy snapshots from branches of Git. And that's our rollback methodology as well. So you can version pipelines, you can version them with snapshots. So you can say, give me a snapshot of this particular pipeline for this stack at this moment in time, and deploy them from the dashboard. And then if you were to roll back, you can go back to the snapshot, or you can switch your branch and have a CI/CD flow that does that. So yes, we do have that. I haven't gotten into that in this particular video.
And one question from Piotr. How does this single node deployment strategy come into your one step equals one node general strategy? Will it evolve, or is it just a fast deploy for testing option?
Could you say that again? Like I missed or maybe I can just read it myself.
It's the second question.
How does the single node deployment strategy come into your one step equals one node general strategy? Will it evolve, or is it just a fast deploy test option? No, that's exactly the point. So we have evolved it already. So this particular deployment is a single node application. Well, it can be multi-node if you scale it, auto scale it or something, but essentially it's a service like a REST API that allows you to run all the steps within one process. And this is not something that we've taken lightly. We've thought about it, and you can do both. So you can do multi-node, multi-step trainings, or you can do these fast single in-process executions, just like you would run a pipeline locally in a local orchestrator, even faster. So yeah, it's not a test option. We want you to deploy agents and models in production with this. That's the aspiration.
And can you say a little bit about scaling? Like how do you handle it? I guess particularly for the cloud deployment options.
So we have a lot of scaling options. So if you look at, again, I think Weather Agent, I'm going to shout out Stefan Nika. You might have seen him on GitHub. He basically wrote a monster of a pull request or an example that basically has every particular configuration you might want for scaling and in real production scenarios. Maybe I can just share my screen again. And I think there you can see it. You have stuff like middleware, like timeouts. You have things like health checks. You have things like on startup, on shutdown hooks. And of course, you can specify how many resources are attached to a particular. Yeah, you can use the resource settings to specify for one single deployment how many memory CPUs and replicas you need. So you are able to control these knobs through ZenML. And obviously, we're relying on Cloud Run. We're relying on Kubernetes. We are relying on AWS App Runner to be able to scale up and down. But those infrastructure tools are actually very good at scaling things up and down. We're just giving you these controls through the ZenML interface and making it easy to deploy.
And we actually also have a nodal deployer coming soon as well. So yeah, just to...
That's true. That's your pull request.
Yes. Another question, when should I use pipeline deployments versus just running a batch pipeline on schedule?
Whenever you need latency, if you don't care about latency, spin-up times and all those things, so if you don't care that SageMaker takes 15 minutes to start your pipeline, then you can use things on a schedule. But if you want things which are warm and it's already basically the Python process has started, ZenML is loaded, then whatever, agent libraries have loaded, and all you're doing is executing very quickly at endpoint, then you should use pipeline deployment. So things like distributed, as I said, eventually we'll have streaming and stuff. So for chat, or if you have a multi-turn conversational agent, stuff like that, you should be using these things.
Great. We had a question from Niall about, I guess somewhere on your screen you showed dynamic routing somewhere, but yes.
Oh, did I leak that? Did I leak that?
Yes, apparently.
I'm not sure whether I should talk about dynamic pipelines because Michael might say that I'm over-promising to the community, but everybody knows that ZenML doesn't have fully dynamic pipelines. We are working on it. We are very close. We have an internal POC running that everybody uses, which has if conditions, which has for loop. I'm regretting this already. So basically, our aspiration with ZenML is that you are able to take any pipeline function and use any Pythonic, code to be able to control the flow of the agent, including if you call steps from within steps, if you have recursive steps. So again, as I mentioned, we need to evolve beyond acyclic workloads. And as I said, we have an internal ZenML version, which we're testing right now, that actually allows for fully dynamic pipelines with caveats. So that combined with this would really be helpful in agents, because you would have maybe an agent that calls another agent that goes into an infinite loop and then comes back, and then you still have all that observability in the ZenML dashboard.
And obviously, we want to give everyone the power. Although I suppose my spicy take on this would be that quite often this stuff is kind of a foot gun, or it can be at least, where particularly in either the multi-agent scenario or so on, where the stuff, you might cause yourself more problems versus just running a straightforward workflow.
I think it's pretty clear that you shouldn't go for a multi-agentic startup at the beginning, right? It's a bit like, over-engineering it's a classic over-engineering, right? Like start simple, start with the workflow that uses an LLM. That's probably going to get you 90% there. If you need some non-deterministic planning, then add in an agent that does an orchestration plan. But again, I haven't really seen this scale in production outside of coding agents like Cursor or specific startups like Harvey that do that very well. Even Harvey, I think, is mostly workflows right now. So yeah, treat these things with caution.
Yeah, for sure. I mean, I can mention the LLM Ops database where we have all of these case studies and so on, and even that is pretty. It's pretty rare to see a company with that kind of setup. The vast majority of people are doing fairly standard workflows.
How far are you with the database? How many entries do you have now?
We're soon to hit 1,000.
1,000 entries, and we're going to shout that out. More people need to read that, like what is actually working in production.
Yeah.
So I'm going to drop the link for the people. So if anybody wants to. Do you have, by the way, Alex, the MCP server for this, or like a way to extract information from the LLM Ops database?
So it is automatically published as a Hugging Face dataset. If you want to just grab all of the stuff locally, there is an RSS feed if you're of that generation. If you want to keep up with the latest of what's coming out. But I do every 100 or so, I try to publish a blog post just to say, what's changing, what new things are we learning on our blog. We had one more question just before we run out of time, Hamza. From Thibaut asking, is there a plan to facilitate the creation of like a version data set to benchmark the deployed pipeline using custom metrics, whether using Ragas or I guess there's a question about evals. How does ZenML deal with evals of these agentic endpoints?
So the goal is that you run evals in ZenML pipelines. So basically what you do is within ZenML, you are able to see all of your pipelines. So let's say you have a particular pipeline that is the actual agent. Maybe you have a SLM that you trained, that's here as well. And then maybe you have an eval pipeline, which maybe uses Ragas, maybe uses deep-eval, maybe uses something else, or maybe just uses your custom evaluation. And our goal is that you see all your artifacts here. So you see, maybe I have a good example.
Your golden data set would live in ZenML.
I think we have a good example in the Agents in Production project that we were working on. So this is an example of a eval pipeline, right? So what I did was I had some conversations that I loaded from real world. You can see what they are. So they're basically just conversations that users had. Then I trained an intent classifier and I created many prompts. So prompts are also modeled as artifacts in ZenML. I think that's something we're going to double down on, make it a bit easier. And then we have 3 architectures that run, and ultimately you have a comparison report of which agent performed better. So did the LangGraph one perform better? Did the multi-node one perform better? You can store all these things within visualizations in ZenML, or you can store them as metadata and compare them. So our goal really would be to have your eval pipeline, your training pipelines, your aging pipelines all within ZenML, so you have one view of those things.
Nice, but that's also kind of an abstraction or a feature that we'll continue to work on going forward. I think we've hit time now. So yeah, thank you everyone for showing up. It was really fun to demo this in front of you all. And yeah, please, if you're not a member of the community already, please do join us on Slack. Try out pipeline deployments. Yeah, we'd love to hear back from you. Your feedback is super useful for us at this stage in particular.
Thank you, guys. Give us a star if you haven't.
Yes.
Thank you.
Thank you, everyone. Bye.
Bye-bye.